Welcome back, everyone. Our next topic is Canadian AI Research for Good. You've heard that phrase a little bit already today. As in the last session, we'll look forward to addressing audience questions at the end, and I invite you to submit your questions throughout our discussion using the Zoom Q&A function. And so what do we mean when we say Canadian AI Research for Good? Well, as many of you know, the rapid pace of AI development has already had a major impact across sectors, and it shows no signs of slowing down. So how can we, as AI researchers and developers, ensure that these technologies will benefit everyone and that the race to deploy AI won't supersede important principles like privacy, security, ethics, and equity? And so audience, let's get you active on the chat. What do you think? What are the top 3 things that come to mind when you think of Canadian AI Research for Good? Send in your thoughts on the chat. And so while you're doing that, I'm excited to welcome some of the newest members of the Canada CIFAR AI Chairs program. Each of our chairs are leading important research in areas that will have a real positive impact on society. And so I'll invite Mo, Nidhi, David, and Rahul to turn on your cameras and join me on screen. And let me introduce my colleagues, the 4 of the new Canada CIFAR AI Chairs. With us today, we have Mo Chen, an Amii Fellow and Assistant Professor at the School of Computing Science at Simon Fraser University. That's what he's got in his background. Mo's research specializes in developing safe robotics. We have Nidhi Hegde, an Amii Fellow and Associate Professor at the Department of Computing Science at the University of Alberta. Nidhi is building machine learning methods that allow technologies to operate while at the same time protecting our privacy. David Rolnick is here. Hi, David. He's a faculty member at Mila and an assistant professor at McGill University's School of Computer Science. He's also one of the co-founders of Climate Change AI. And one of the areas that his research focuses on is using AI in the fight against climate change. And we have Rahul Krishnan. Rahul is a member of the Vector Institute. He's an alum of the University of Toronto, and he is returning very shortly to take up his first faculty position in Canada as an assistant professor of computer science and medicine. Rahul's research is using machine learning to understand how disease progresses over time using electronic health records. Thank you to the 4 of you for joining us, and congratulations once more. So let's have a great discussion. I know our audience will have lots of questions. Don't forget to send those in using the Q&A function. And we'll start with just a few structured questions before we get to the audience. And so I'll ask, in fact, each of you to describe your current research and tell us what ways your research can be applied to deliver positive social benefits. We're going to start with Mo.
Okay, yeah, thanks so much, Elissa, for the introduction and for hosting the event. So I guess I can talk about my research for a while, but maybe I'll give the short version. So my current research aims to enable robots to behave safely and naturally among people. So we work on topics such as human intent inference, collision avoidance for mobile robots, multi-agent coordination. So our techniques can be applied to indoor places like schools and stores, and also outdoors as well. So I think the key here is to be safe, for robots to be safe but still useful. So of course, a robot can be completely safe if it operates far from people, or if, for example, a self-driving car is just staying parked, right? But we need to to go further than that. We need to walk the fine line between interacting closely with people and still staying safe and hopefully trusted eventually.
Yes, so robots can eventually be our partners in much of the work that we do, right?
Right, yeah, yes. So maybe getting a little bit more technical. So our methodology involves control theory, reinforcement learning, computer vision. So for example, we try to adapt safety verification algorithms that are used in the aerospace to crowded environments on the ground. We also try to combine classical optimization techniques with data-driven learning-based methods. So we have several examples of that. Like one of them I like to bring up is we try to use learning-based methods to do higher level planning, like where the robot should go next at a high level. And then the details of how to get there safely can be taken care of by some of these classical algorithms. Yeah, so I guess you asked the second part of the question, positive societal benefits. Autonomous robots today are often used in controlled environments like warehouses, or maybe in the absence of other agents like robots and people. So hopefully my research will allow robots to interact with people more closely for applications such as like maybe a robot assistant, delivery vehicles, autonomous cars. And for example, in one project, we put a collision avoidance system on robots, and then we have students try to drive a robot into a wall or into obstacles in unknown environments. And they try, but they fail to cause a collision. So that's a really cool experiment. And we're also working on something called a follow ahead project, where a robot tries to autonomously stay in front of a person. So kind of imagine you have a shopping cart, but instead of you pushing the shopping cart, it's kind of just pushing itself in front of you. So I think I'll stop here.
Those are some great examples of fun graduate research projects going on in your lab. Thanks for sharing those. Nidhi, over to you. Tell us about your research and how it's driving towards delivering positive benefits for society.
Yeah, hi, Elissa. Thank you for the introduction and for hosting this very interesting event. So my current research is in looking at privacy and fairness in machine learning. So what I'm interested in is looking at real practical problems where some of the current privacy preserving methods don't really fit very well, and what are the fundamentals that we need to work on in order to get that working. So for example, a lot of data is structured. For example, the data that you're producing when you're on social networks, which means, a data point is not necessarily independent of the other data points. There's related somehow, and this could be, for example, in the structure of a graph. If we apply standard privacy preserving methods, then this doesn't scale well to the size. So we can't look at large data sets anymore. The noise, the privacy cost that you would need and the compute power you would need would quickly be prohibitive. So I'm looking at that kind of question. Another example is, let's say, different partners in machine learning and AI want to share data, but we don't want to share actual data because of privacy concerns. So we might want to create synthetic data sets and share those. But synthetic data sets are not private by themselves, so we need to do something else to make them private. There are some methods out there, but they're very specific to certain tasks. So how can we generalize this? And another interesting problem is, how does privacy interplay with fairness? Can we have both in a particular machine learning model? Some preliminary work has shown that it's not possible for all conditions to have both. So how do we make sure, can we devise new algorithms that make sure that we can have a privacy preserving outcome that is also fair?
Your research really sort of reminds me that, we need to strike such a fine balance between privacy and data access in order to be able to do the machine learning research that we've been talking about today. Of course, researchers need access to data. And so that's why your work is so critical. Any other thoughts on the social benefits?
Yeah, so obviously, by the definition of the problems I'm working at, it has obvious social benefits. Machine learning, AI really impacts every part of our lives. So anywhere that we can limit damage or harm, like privacy breaches or biased outcomes that lead to decisions that impact people in their daily lives, for instance, is important. So, this type of work has a clear end goal, which is to safeguard people from, potential outcomes.
And impacts on all of us as individuals. Yeah, great. Thank you very much. Rahul, over to you. Tell us about your research and its opportunity for positive social benefits.
Thanks so much. So I thank you again for organizing this wonderful set of talks and panels. My own research, maybe I'll start with a bit of historical context. And so over the last 3 decades, there has been an increasing realization that a lot of the healthcare data that's been digitized by hospitals as they went to record how patients interacted with the healthcare system can be of use beyond the original intent that these records were created for. So originally, a lot of these healthcare records were created for bookkeeping and for billing purposes across North America. And in the last few decades, what we've seen is that people have been interested in understanding how the patterns that lie within these data can be used for the creation of machine learning models to automate clinically meaningful tasks. And so why might that be interesting? Well, for one, we know that access to healthcare and the quality of healthcare access that people do have is not equally distributed. So part of the pitch for this line of work is to help transfer some of the knowledge that may exist in high resource settings to lower resource settings via the use of predictive models in machine learning. And so more broadly, my work lies at this intersection of machine learning and healthcare, and within it, I do research both in applied areas as well as more methodological areas. And so to give two concrete examples of some of the applied work that I do, one is on this idea of patient risk stratification, which is to say, can we use algorithms and models for machine learning to find patterns in patient data to predict whether or not they will have adverse outcomes in the future? Now, at the outset, this looks like a fairly standard predictive problem, but I think once you delve into it, you begin to understand some of the nuances that exist, because healthcare data is not as clean as some of the data that exists and is commonly used in machine learning. There's many potential biases that one has to navigate in order to ensure that the underlying model that's being learned is a true and good model of a faithful model, rather, of the outcome that one cares about predicting. The second example is that of disease progression, which is to say, doctors often collect large cohorts of patients that who all suffer from a common disease. And so in the context of that problem, one interesting question there is, how can we use this data to understand diseases better? Which is to say, does diabetes have predictable patterns of evolution within a human population? And if we were able to use machine learning to discover those predictable patterns of evolution, can those then lead doctors to ask new and interesting hypotheses about how to treat the disease better? So really using machine learning as a tool for hypothesis discovery. And what I found during the course of my own research is the fact that these problems will often require new machine learning advances as well in order to be able to tackle them effectively. So in the past, I've worked on new algorithms for probabilistic inference and nonlinear models, as well as new techniques to reduce the sample complexity, or rather to reduce how data hungry these models are. Because often in healthcare, one does not always have access to millions and millions of samples in order to learn these machine learning models. So in the future, I'm interested in thinking about how to make use of some of the advances that we have in causal inference to build automated clinical decision-making support tools, as well as thinking about some of the nuances of deploying machine learning models in hospitals. How do we tackle issues like the fact that our distribution of people changes over time? It's not the same people going into the hospital, and that has downstream effects on how well any deployed machine learning algorithm performs. And finally, to tackle this question that you asked of societal benefit, I think there's a few ways in which this broad area can deliver some form of societal benefit. And this is particularly true in the case of Canada, where there's where the provincial systems are set up in a way to provide healthcare for everyone. And so one is in the context of early prediction or risk stratification for chronic diseases. There are certain diseases where if you were to predict early that a patient is at risk for continuing on to develop that disease, there may be interventions that one can take and prevent the development of chronic versions of that disease in that patient. And so diabetes is one simple example of it, where if a patient is put on a diet and exercise regimen prior to the development of chronic diabetes, they can often stave off some of the comorbidities that are associated with that disease. And so this is a case where predictive models can lead to interventions, which can then lead to better public health outcomes, both from a cost perspective, but more importantly, from a human health perspective. The second is in the context of developing these predictive models and deploying them in some of the lower resource settings, where and in doing so, reduce some of the inequality that exists in access to healthcare. So I'll conclude with that, and I hope I answered some of the key questions that you asked.
Good. Thank you for going into your areas of interest and some of the issues surrounding AI for health research and innovation in detail. You know, it's an area I think that we have tremendous opportunity in Canada to really play a leadership role in understanding how AI and machine learning can be applied within Canada's healthcare systems, the many multiple systems we have in each of our provinces and territories. But we have such great expertise in this country, and I think a lot of will to think really critically about deploying AI within our health systems. And a huge part of what we have to do is work with citizens and patients and the public to help them to understand what the benefits are of bringing AI into our systems. And I think they're multiple. So thank you for your work on this topic. David, last but not least, your work is really fascinating. Tell us about your research and its positive impact on society.
Thank you so much. It's a pleasure to be here. I work on applications of AI to climate change, so helping society to reduce greenhouse gas emissions and also respond to the effects of climate change. And that means applications in areas like energy and transportation, buildings and urban planning, sustainable forestry and agriculture, ecology, and disaster response. Now, climate change is a huge and multifaceted problem, and AI is not going to solve it. It's not a silver bullet here, but it can be a powerful tool for particular problems. For example, AI can help distill large amounts of information to help policymakers make decisions. For example, by using satellite imagery to automatically monitor greenhouse gas emissions or land use or monitor ecosystem change. It can also help optimize complicated systems. So for example, reducing the energy required to heat and cool a building or improving the efficiency of freight transportation networks. It can improve forecasting, for example, of agricultural productivity or food insecurity. And it can also accelerate the process of scientific discovery itself by speeding up the search for new materials like those in batteries or in photovoltaics. If you're interested in the full space of where AI can be helpful in climate change, we actually put out a 100-page paper with recommendations that's designed to help guide this field moving forward. But let's dive into an example from my research group. One of the challenges to using more solar and wind power is that these sources of power vary from moment to moment, depending upon whether the sun is shining or the wind is blowing. That means it's really difficult to control an electrical grid with lots of renewables because the available supply of electricity is always changing. So basically, grid operators need to solve a large non-convex optimization problem. It's called AC optimal power flow, or ACOPF, in order to manage the grid. The existing ways to do this are very slow, but the problem actually needs to be solved every few minutes if you have a lot of solar and wind energy. So in practice, people have been radically simplifying ACOPF in order to make it more tractable, and these solutions are just not very good. My group just released a deep learning algorithm that makes it possible to derive good and fast solutions to ACOPF by encoding the constraints in the problem statement, essentially providing a guarantee that the lights won't go out, that it will satisfy the constraints in the electrical grid. And previous deep learning algorithms on electrical grids couldn't do that, which, as you can imagine, made people much less likely to apply them. Because if you're a grid operator, you really want to make sure the lights don't go out. So our approach actually not only works for ACOPF, but it also works for big non-convex optimization problems in general. So it's very broadly useful. Some of the other projects in my group are semi-supervised remote sensing approaches for monitoring biodiversity and ecological change, and fast approximate simulations of atmospheric physics to integrate into large weather and climate models. The existing models are great, but key components of them, like as with the electrical grid, can be very slow, and machine learning approximations can speed some of those components up. Really, a key aspect of our work across problems and application domains is close collaboration with domain experts and other stakeholders like the Montreal Insectarium and Environment and Climate Change Canada to ensure that the work is guided by the societal benefits and is deployed impactfully. And as Elissa mentioned, I'm also co-founder and chair of the Climate Change AI Initiative, which facilitates work at this intersection of climate change and machine learning. And we cultivate the global network of researchers in this space. We organize workshops and advise stakeholders and put out grants and other resources.
Great. Thank you, David. As I was listening and thinking about all of you and your research, one of the things that struck me, and David noted it specifically, is it's highly multidisciplinary, right? So you all, because you want to apply your machine learning tools and algorithms and approaches to real world scenarios, of course, you have to work with people with diverse expertise. And so that, I think, lends a real richness to your research and real opportunities to engage scientists and researchers outside of computer science in the application of AI. It's very exciting. And then the other thing that struck me too is that there are huge policy questions related to all of your work as well too. And so there's another huge group of stakeholders that we have the opportunity to work with and share and talk about our research so that they can become more involved and understand the challenges and opportunities of applying machine learning to some of these policy questions as well. It's great stuff, guys. Okay, so I'll go back to my script and stick to the questions for a few minutes. So all of you are taking up your first faculty position in Canada, it's fabulous. We're so happy to have you. Can you tell us each, why did you choose Canada and the AI Institute that you're affiliated with as the right place for you to be pursuing your research? And I'm going to start with David on this one.
Sure. So I don't think I need to convince this audience that Canada is at the forefront of innovation in AI. I'm really thrilled to be a part of the CIFAR AI community, both at Mila and across Canada. One of the things that I really love about this program is that it represents, as Elissa was indicating, really an exceptional opportunity for synergy between research, industry, and policy, which is essential for enabling impactful AI work on topics like climate change and many other topics. Innovation in AI doesn't exist in isolation. It should be driven by problems of relevance to society, and it should be developed in conjunction with the various relevant stakeholders. So those stakeholders can include researchers in other fields like energy, agriculture, or ecology in my case, but also the companies that are often involved in implementing AI innovations, and the policymakers who help shape the overall space, and very importantly, end users, people, and communities. And CIFAR represents an opportunity for communication between many different voices. This is not just the way to build tools that are most beneficial for society, but it's also the way to drive breakthroughs in AI itself. So areas of cutting-edge AI research like hybrid physical models and interpretability are spurred on by the needs of end stakeholders to incorporate known system constraints in this case, or to better understand how the algorithm is working. These are the needs, and that leads to innovation. So the right kind of research ecosystem really benefits everybody.
That's great, thank you. Nidhi, what about you? Why did you choose Edmonton? And Amy?
Well, actually, I'm originally from Edmonton. And I was away for many years. This is my first faculty position, but I've been working for about 18, 19 years in industry research, and most of it, about 17 of those years, in France. So this was a great opportunity for me to not only come back to Canada, but to Edmonton, and to participate in this wonderful ecosystem we have here. I echo what David himself said here about CIFAR giving us this opportunity to make these short connections between different parts of the country through Amii, Mila, and Vector, which gives us, a wide range of people we can collaborate with. And topics like the one that I'm working on, it's really important to connect with different disciplines, researchers. Privacy impacts health, for example, and it impacts, other services like recommender systems. So this is a great opportunity to be able to connect with people of different disciplines. And being in this academic environment, I'm also able to connect with other disciplines like law and sociology and business, for example, where we are starting to see a lot of impacts of AI as well.
Absolutely. That's, again, that multidisciplinary collaboration is really what's key to driving these technologies and making sure that they're implemented in a way that's really responsible and effective. And so while we're talking about responsible AI, and that's a phrase that we throw around a lot in Canada, you heard it quite a bit this morning from speakers. Rahul and Mo, let's talk about your areas of application. What are some of the important considerations that you think about, or that the community thinks about, in health or in robotics when it comes to ensuring that your ML approaches are implemented in a way that is responsible? How about we'll start with Rahul?
Absolutely. I think the area of healthcare is one where you cannot blindly walk in and make the assumption that any black box machine learning algorithm will perform well. And so this is particularly true for two reasons. One, there exists societal biases that manifest in the data that what these algorithms are trained on, and the naive application of these algorithms might simply amplify the existing biases. Two, knowing what is relevant for the prediction task at hand is often not something that most machine learning practitioners will be well versed about. And furthermore, what is relevant might simply change across the different contexts that the model may be considered to be applied in. So what's relevant in hospital 1 for predicting a patient outcome may simply not be relevant in hospital 2 because the way they do things in terms of their processes is fundamentally different. So I think in the context of healthcare, there's two key considerations for thinking about responsible AI that I think are important to start with, at least, and there's many, many more. And so the first is working with domain experts. I think there's absolutely no substitute for working with a domain expert in an area like healthcare, because he or she is the one who's worked with the data every day of their career, and they arguably know about any limitations that the data may have and can think through the impacts of those limitations on the downstream performance of any model that's being developed. And so the second key consideration, I'd say, is monitoring the performance of the model in any deployed solution. So I think this notion of responsible AI is not it's not a one-off. It doesn't stop when the model is done training. It's sort of a commitment to continue to see how the model performs in a live scenario and monitor it for unintended consequences. And what I want to point out here is that these unintended consequences need not be from what the model is predicting alone. They could be much bigger implied consequences that come about as the model is used in practice. So to ground that in a concrete example, you can think of a prediction tool that, say, predicts whether or not a patient should be recommended for a second opinion in the context of, say, a disease. And so if this model is really, really good at this prediction task, what essentially happens is that you have a much larger volume of people who are now going to doctors and specialists for second opinions, but we have a finite set of resources or a finite set of specialists who may not have the capacity to handle that volume. And so this is an unintended consequence, not due to the failure of the model, but rather due to the systemic nature of the healthcare system that this model is deployed in. And so I'd say that it's important to think about both the micro and the macro scale consequences of deployed solutions of machine learning in this context.
Yeah, absolutely. And both of those examples that you gave remind me of, especially in a healthcare context, this idea of, the humans in the loop, right? So keeping the clinicians very close to the development of the machine learning algorithms and tools that are being deployed. But then, we as practitioners following the evolution of our models as they are deployed and out there in the wild. So that's great. How about you, Mo? Tell us about the considerations around responsible AI when we're talking about robotics.
Yeah, in fact, even though health and robotics, they sound like kind of different areas, I actually think that there's a lot in common. So one of the things that we really worry about is, if an AI makes an error in judgment, it's not just some misclassified image, but in both robotics and health, there's immediate physical consequences to people. So of course, I think safety and sort of the reliability of these systems is really, really important. And I think it's actually one of the bottlenecks that we need to get through in order to kind of advance the field of robotics in everyday life. I think a lot of these keywords I'm going to mention, you probably have heard, like interpretability, right? I think robots will make mistakes, and hopefully not too many, but they will make some mistakes. And when they do, we need to understand why and systematically kind of sort of improve the areas that they're weak at. I think one thing that I'm pretty interested in is to have robots realize when they should be unsure of themselves. So if you have a driver, let's say a human driver or a human a doctor, right? Especially during training, training is now kind of an overloaded term now. People know when they should be unsure and maybe when they should ask help, right? This is something that I don't really think robots can do yet. and hopefully they will be able to do this later. One thing that is also very important for robotics is how can we learn safely, right? One of the ways of learning safely is in simulation. And so can we develop methods that can robustly transfer behavior learned in simulation to the real world? So this is a very active area of research. So in the end, I think that one of the really more complex things that I want to consider is really people's trust. So suppose we make these systems very technically robust, technically speaking, they're very, very, let's say, safe. Will people still trust them, right? A lot of times we've seen user studies where the robot is behaving optimally, but people feel that the robot is acting weird. And even though the robot is doing probably better than humans don't necessarily trust the robots. So in terms of trust, I think it's a very, very difficult topic. I think one thing that we have to do as a community is to make sure we educate everyone, right? Not just the students, but the entire community, including people who have already been working in AI, right? We need to understand, like we can choose to trust AI or maybe be skeptical, but the trust or skepticism, it needs to be informed. And I think as a community, this is a very important thing in the long term.
And any thoughts, Mo, on how we should do that? You know, you're talking specifically, I think, about the research community. I and my colleagues at CIFAR have been thinking about the public and engaging the public around AI. Do you think we have to do both?
Well, obviously, I'm kind of focused more on the education of students, right? The graduate students as well as the undergraduates. This is kind of running into the maybe like advice for students. I think.
Go ahead.
I would say like we need to learn the fundamentals properly. There are no shortcuts, right? So a lot of times when we think of AI, we think of perhaps downloading some toolbox that makes doing research convenient. But those should be more like a jumpstart, right? There's still no shortcut in learning the math, learning the fundamentals. And Canada being one of the places where we really value fundamental research, this is especially important. And I would say this extends not beyond students. This is also for everyone involved. I've talked to many of my friends who are actually well educated and they are aware of AI, but I would say that in general, I really hope to see people understand the fundamentals a little bit more.
Great.
And maybe more events like this, in fact, that could help.
Yeah, that's part of why we do it, for sure. Absolutely. Okay, I'm going to take a few questions from the audience now. We've had lots of great questions come in, and I want to share one with you that's particularly been upvoted by a number of individuals and people putting their thumbs up for this one. It's coming in from Joshua, so it's a loaded question. What should happen to make sure AI for social good applications are developed, even when the profit motive is not sufficient to motivate companies? So, how do we make sure that, AI for good applications are really a priority for us as a research community, a research and innovation community, when the private sector and their profit motive is not high enough for them to be involved? Thoughts on that balance? Anybody want to join?
Well, I'd like to start by saying it helps to have a monetary incentive, obviously. But when that isn't there, I think in the research community can fairly easily be convinced that this is an important problem to look at. I think the community that needs to be convinced is the industry, the business, and the general public. Sometimes they're just not aware. And possibly even, I believe in a multi-pronged approach, so possibly even sort of the regulatory or policy bodies. One analogy I like to use is, industries like telecom, where I worked for many years ago, have standards that their protocols must abide by. Now that's important for the communication, but for areas where you don't need that, you still have certain guidelines. Like many years ago, the consumer protection agencies were very important, and their work led to things like having labels on clothing irons that say, "Don't iron while you're wearing your clothes." So, no one's saying that clothing irons shouldn't be produced and shouldn't exist, but the harm that can be produced from it was recognized. So in the same way, I think for AI products and services, I think we all agree that they're very important and impactful, but the harm that they may result in is not properly recognized. And so maybe, we need something like these consumer protection agencies that allow people to be educated about the harms and how they can be safeguarded. So if the people are then aware of this, then they can push using their, where they spend their money on, they can push the industry or businesses in certain directions.
Yeah, absolutely. I'm reminded, again, to go back to healthcare, where it's, a highly regulated sector in Canada and the US, and both the FDA and Health Canada, actively and carefully examine machine learning applications very closely before they're implemented within health systems. And it's happening. And so that's a step in the right direction. Anything else on public, private sector? Go ahead, David.
I can step in a bit. So I think that one component is using our voices, not necessarily in a research capacity, but in the capacity of thought leaders to add to the conversation about what best policies and best practices are. We have leadership roles that don't involve necessarily coming up with a new algorithm. It is important for the community to use its voice in that way. And then I think another component of this, and that does involve informing stakeholders of what the capabilities of systems are and what they can do to best incentivize meaningful impact. And that also means informing ourselves what that means. But I think another component is remembering that research needs to be scoped with impact in mind from the get-go. It's not a question of I wrote a great paper with a great project and now I'm going to look for a way to make it impactful. Oh, wait, I don't see a path to impact. This is why one should work with stakeholders from like the initial scoping of a project and the development of the project in addition to the deployment of the project. Because once you get to deployment, if you haven't scoped it together with the people who will ultimately be using it, it's too late. There are a ton of opportunities where the incentives are aligned right now, and making sure that one is working with the people who will be deploying your projects can help you ensure that you are working in a space where you will be able to have the impacts that you want.
That's great, David. Thank you for that. And actually, your response speaks to one of the other questions that came in that reads, what do you see as the role of individual researchers versus the organization or external players like governments in ensuring that AI is used in socially beneficial ways? So I want to sort of share that one with the other members of the panel. What do you see as your role as individual researchers in, being a voice around responsible use of AI? Anybody?
Yeah, I can chime in on this. I think as individual researchers, we serve two roles. One is education, which is educating students, be it undergraduate or at the graduate level, and teaching them to create new algorithms in machine learning, in robotics, in healthcare, and climate science. And I think that educational component of it is a big part of the role that we can play in order to make sure that the effort that we put in is multiplied by the students who learn from us. And as long as we inculcate in them a sense of responsibility, a sense of values in how to ensure that these applications are used responsibly, I think that's one of the most impactful ways that we can help, because ultimately that's who we spend a lot of time with, the students. The second way is, I think I agree with David, as having our voices heard in a variety of different scenarios and ensuring that the ideas we put forth are ones that are consistent with these notions of safety and responsibility, and responsibly using the more technical approaches that we develop.
Great, thank you. Okay, I've got 2 minutes left on the clock, or maybe even less. So we're going to switch to sort of final thoughts. And I'd love to just have each of you give us in sort of 30 seconds, let's call it 20 seconds or less. Tell us your best advice for graduate students interested in your particular area of machine learning. What should they be doing now to prepare for their future careers in academia and industry? Mo, we'll start with you.
Yeah, as I mentioned earlier, we need to learn the fundamentals properly, right? No shortcuts. We need to, in robotics, we need theory, how the theory translates to code, and how code translates to robots moving in the physical world, right? And don't be afraid to collaborate with other faculty members other than your supervisor. And internships are great. So just get all the expertise, all the expertise wherever you can get.
That's great. Thank you. Nidhi, your best advice for graduate students.
So I think my topic is necessarily multidisciplinary and necessarily has a clear and immediate impact on society. So I would suggest that they make themselves aware of actual real impacts, like real examples that, journalists have investigated on where privacy breach has occurred or where fairness or bias questions arise. I think that's important. And also second what Mo said, which is understanding the fundamentals, because things like privacy and fairness, sometimes they're even hard to intuitively say what they mean to us. And they may be even harder in a mathematical way to define what they are. And that's really important. We need to be rigorous about these definitions and about how we derive these in order to then create algorithms that mitigate these problems. So the fundamentals are important and multidisciplinary. Don't be afraid to talk to people in law or in philosophy to get a more well-rounded understanding.
Absolutely. Rahul, over to you. Best advice for grad students.
Yeah, I think there's two pieces of advice that I would really have. I would echo Mo's thoughts on a focus on foundational knowledge. So when you think about classes, don't think of them as I want to learn the most advanced topic first. I think it's very much in your interest to take the more foundational topics on linear algebra, optimization, stochastic processes. And really this is because machine learning is fundamentally just a melting pot of different subdisciplines. And it has always been that way. And so being very good and having strong foundations is crucial to any future success in this sub area. And the second thing that I'd say is, in at least what I found when I was studying, is the fact that I think patterns are sort of universal. And I think if you learn to recognize patterns that exist in different classes that you're taking, and have a conceptual framework by which you can learn to manipulate them, that's an incredible skill to have, because at the end of the day, a lot of ideas are rediscovered and reused in different subfields, and being able to flexibly move within fields and describe how one idea relates to another in a completely separate arena, it will only strengthen sort of the mental models you have of the world and ultimately lead to more interesting kinds of research ideas.
Great advice. David, last word to you.
Yeah, so to echo what other people have said, learn the fundamentals, but not just machine learning, learn the fundamentals of whatever areas you're looking to integrate with machine learning, and go in with humility. Recognize that each of these other areas of application has decades or centuries of great work in it, and machine learning is not suddenly going to solve all those problems. Or if it does solve some of those problems, it's going to do that only by integrating with all of that existing knowledge, and by really carefully working with people who are expert in those areas. And if you want to have an impact, start from the problem. Whether it's a theoretical or an applied problem, start from the problem and let the tools that you use evolve to match the problem. Don't go in assuming that the fanciest, newest tools are best. And then paradoxically, often that is actually what will lead to foundational innovation. That is what will lead to the breakthroughs from an algorithmic perspective too, is really being driven by what people need.
This is great advice, and it's been such a fabulous conversation. I hate to have to cut it off, but I'm afraid that is all the time we have for today. So thanks so much to all of you, all of our panelists, for sharing their insights and experiences. We're really thrilled to have you as part of the Canada CIFAR AI Chairs program. And thanks to the audience for great questions and discussion over the chat. This has been fantastic.